There we go. So that's the all-in-one. It's unique because a lot of competitors do not do this. So it's something different that we all have to get used to. So the finger pointing is only Kyntronics. We're the owner in regards to the all-in-one. Nobody else to point the finger to. We own the solution. So the product comparison versus the EMA. This is another important part of it, apples to apples. The customer's purchasing agents looking at our quote, looking at the quote from Acme Distribution, Actuator, hey, you're $3,000 more. We went through this before. Of course, there's, that apples to apples situation. So obviously everything down here is itemized, but it's still not the same as it all being wired up and tested and integrated together. Another important point is reliability in regards to the product comparison. Give you a quick example of a recent application. So this customer, decent opportunity, they went out looking for an actuation solution. They're looking at a roller screw solution as well as ours. And they're being open, they're sharing theirs with us and ours with them. And when we're looking at the application that the customer went out for bid for, we met their needs, and assuming that the competitor of ours met their needs. Looked at the competitor, what they was offering, and our educated sales team went to the customer to educate them, stating that, hey, this particular actuator, it's not going to last, the roller screw actuator, and convinced them to go after the roller screw provider as well as their distributor and said, hey, this thing's going to last 6 to 8 months. What's going on here? And challenge them regarding the reliability of that actuator. To back and forth, they actually came back and said, you're right. And quoted a much larger actuator, bigger motor, bigger everything to get it more reliable. But at the end of the day, they lost credibility and likely they lost the order. Because if we weren't involved, they would have supplied an inferior product and it would have been a failure for the customer. And in 6 to 8 months, they would have had to deal with warranty and returns and everything else. So this is just an important aspect to weave into your conversation with the customers, is the reliability side of things. So why is the SHA reliable? It's that simplicity thing. There's not a lot going on, and the more simple, the more reliable it's going to be, and vice versa. The more complex, the more failure points, opportunities for failure. So what's going on here? So you have this servo motor. It's coupled to a coupling that's coupled to the gear pump. Gear pump just rotates. The motor rotates clockwise, for example. Fills in the red side, pushes the actuator up, rotates counterclockwise, fills in the blue side, and pushes the actuator down. As you can see, the volumes are different between the blue and the red. So when the actuator is coming down, that fluid needs to go somewhere, and vice versa. When the actuator is extending, it needs to pull. And this green portion here is your reservoir. And it just stores the fluid so it can go back and forth. So it's relatively simple. Again, a simple system leads to reliability. There's not a lot of parts going on here, no binding, no mechanical binding, any strokes available. It is an extremely efficient means of moving in linear motion. No hoses, no thread connections, it's just a positive displacement reversible pump. The circuit itself is, again, simple. Not a lot going on. The motor rotates clockwise, as I mentioned. The red extend. Fluid comes out of the blue or goes into the reservoir, rotates counterclockwise. It's a relatively simple circuit. You can also have options of various valving. You have a cavity plug or check valve if you need to lock in place or counterbalance for overriding loads. So we consider all kinds of different situations there. Any orientation the actuator can go in, and again, it's a very efficient 4-quadrant control. position force control is all available. Well, you say, yeah, but it's got fluid, and a lot of people don't like that hydraulic fluid thing. The EMAs have grease in them. They got fluid in them. Of course, if there's a gearbox, it's even more fluid. HPUs have fluid. Even in a worst case scenario, tow motor runs over the actuator, you're just going to have a couple of Coke cans of fluid that you're going to have to mop up. So it's not a lot of fluid. This is an example of a 10,000 pound force actuator, 8-inch stroke. It only has 14 ounces of fluid. So a minimal risk of fluid contamination or fluid spills. So this is a very good solution out there regarding the EMA replacement, etc. Some of the benefits I want to just highlight regarding hydraulics versus an EMA. An EMA, in order to hold position, you have to add a brake to the actuator. Of course, the brake has, you have to energize the brake. It takes away power. You have to energize the brake during every move. Not every move, but you have to energize the brake. It takes time to energize the brake, and then you move. And our solution, it's just a check valve. Simple little check valve that goes in and a lock in position as soon as you stop. The fluid stops, the check valve is engaged. No brake required for the SHA. Force density, hydraulics is well known for its force density, versatile configurations. Fluid in any direction. There's all kinds of different orientations to fit in the machine. We haven't had an issue yet. We had to be creative a few times. But again, with fluid, it's not an issue. With gears, it's difficult to move gears and belts and various things around. You have an inline and a right angle, that's about it. Force control is another advantage. For an EMA, you have to have a flow cell to do accurate force control. A conditioner, it adds complexity. Ours is relatively simple. It's just a pressure transducer. You know, the area is fixed. You know your PSI from the transducer. Again, it's simple. Closed loop force control is available on every actuator as needed. Reliability, again, a huge benefit over the EMAs. It's a very simple solution, more reliable. Side loading, impact, and ingress protection, those are some of the things we're going to dig into in the next few slides. Just wanted to go into, you guys have a gear pump. So you guys are going to have issues with wear as well. Well, that's not true. The gears are all encased in fluid. You have these pressure plates on both sides of the gear. And in between the pressure plates and the gear is a lubricating gap. There's some magic science with this stuff. It's very complicated regarding tolerances, etc. But everything needs to be lubed in here. There's no metal to metal between the gears. The gears push the fluid. Everything's lubricated. There's hydrostatic seals, hydrostatic bearings throughout the shaft, etc. So as the gears rotate, there's fluid moving all over the place, so there's no metal issues here. Just an FYI in regards, this is basically a gearbox. This is our gearbox. So when we need more speed, they increase the length of the gears. The gears are all shiny, high polished for all kinds of different reasons, but you just increase the size of the gear and that increases your flow. The gearbox, if you have your ratio of 6:1, and you either increase your speed or increase your load, and vice versa happens. If you increase your speed, your torque goes down. But now with this, so you increase your speed, you can still maintain the 3,000 PSI as needed. Of course, you're going to need more power, but that's still all available. Liability going on in this presentation so far. The third time we've brought this up, but yes, it's an important point. The more load, the less reliable the EMAs are, and the SHA is load independent. You can understand, as mentioned, the complexity of a EMA, roller screw, etc. The more complex, tight tolerances, all kinds of reasons for binding and causing potential failures. In this example, just wanted to point out on a press example that you see the two gears in red. Every single time that press presses, let's say 10,000 pounds right now, those gears are locked together, same place. All the mechanics are being locked together at the same place, same time, every time you're doing a press. Again, leading to premature failures. Just to recap, some of the things affecting the EMA's life, again, loading, it's not dependent on an SHA. Impact loads, we'll get into a little bit here. No issue with the SHA. Side loading, major issue with EMAs. It's an issue with everything, but there's ways to get around it. We'll talk about that a little bit. And lubrication, always lubrication. You got to lubricate the EMAs all the time. With the SHA, it has oil in it. You don't have to lube. There's no lube required. Actuator choice for reliability is the SHA. Impact and shock loads. EMAs are well known to have issues with shock loads. Even if you were to run the actuator, say jog the actuator all the way into its own stop, there's a likelihood of jamming all those components together. All those potential, again, it's complex, more likelihood for reliability issues. And binding it regarding shock loads, little balls, issues, and potential situations. The SHA, as I mentioned, it's relatively simple. There are no mechanical parts for binding situations. You have that shock load with a virtually incompressible fluid. Not an issue for SHAs. Again, the SHA is the actuator of choice regarding the impact and shock loads. Side loading, we're all familiar with that. There's all kinds of app notes, various fine print in the EMA world saying don't do any side loading. It's imperative that the nut and the screw are not exposed to side loading, only axial loading. If you know that incurs binding, it definitely can cause potential for failure. Balls, contact points, they can roll up the non-hardened spots, causing wear and premature failure. Again, the more complex, the more opportunity for failure. Lever loads, you see a lot of hydraulic actuators on dump trucks and all kinds of various things having the lever loads. EMAs do not like that. SHAs deal with it. How do they deal with it? Again, for some side loading, we also promote, try to avoid it, but there's ways, if the application, lever arms, various things have a side load, there's various ways to deal with it. So you can see here the distance between the end of the piston and the bearing is a certain amount on our standard actuator. In most cases, it's no issue whatsoever. To increase that distance, again, side load here doesn't affect so much over here. You can, and that's done with the stop tube, add a little stop tube in there. Another example is you can go with a larger piston or two pistons, further increasing this distance, again, being able to compensate for side loading. These are just a few examples of how to compensate for some side loads. Again, the EMA doesn't have that capability, and the actuator of choice for side loading is the SHA. Ingress protection. We talked about this before. Ingress protection are rated in regards to EMAs as static. And when they start moving, they lose that ingress protection. It's no longer an IP whatever. So in all their documentation, you have the S at the end, static, IP65 is static. As soon as it starts moving again, you lose that. Ours is IP65 out of the box. We can go higher as needed. We got to make sure the hydraulic fluid does not get out. And while doing that, we make sure no fluid and contamination can get in. Same situation regarding ingress protection, the actuator choice is the SHA. So switching gears a little bit, wanted to talk about some power calculations. Before I jump into this. So one recent customer gave us some specs, 5,000 pound force, and said they want to go, well, I don't know, 3 to 4 inches per second. Well, you know, the customer's always right, but going from 3 to 4 inches per second is a 33% increase in power. And that's just one point I'd like to just try to get across. A lot of you, it's obvious, I'm sure, but some customers, it's not. Just going from 3 to 4 is a 30% increase. So you're going from 6.5 horsepower almost to 9 horsepower, just between the 3 and 4 inches. It doesn't sound like a lot, but that affects, again, the power. So we keep everything the same. So let's say, for example, they have an application running out there at 5,000 pounds, 3 inches an inch per second, and they require 6.5 horsepower for their application. They're looking to upgrade. And they know what this costs, and they ask for, I just want a little bit more. So they say, give me 7,500 pounds. Well, that's a 50% increase. It would be a 50% increase in power as well. Well, if I'm increasing my force a little bit, I want to increase my speed a limit. So let me go a little bit faster, just an inch and a half more, inch per second faster. That's another 50% increase in power. So you're going from the original 6.5 to almost 15 horsepower just by tweaking these numbers. So what we've seen, and I'm sure you all have seen, is the customer giving a little bit higher numbers than are needed. That affects cost, of course. That affects the apples to apples comparison. It's just something to be cognizant of as we're going through things. Increase the force, increase the speed, you're increasing the power. We're talking about software. Position control, force control, position with force limit, and force position limit. Won't get into too much detail. Just wanted to point out on this press application example that all of this is available today. It's our standard. Position with force limit is the most popular, especially with presses. You're in position mode, you switch over to force, do your force at the end, and you switch back to position. It sounds relatively easy. Our system does that seamless. There's a lot of programming behind all of that to switch between a position controlled mode into force mode without interruptions, and doing that seamlessly is what we do. So the example here, you see it's in position, it's going down, it's going to be doing a switch to the force mode, switches to force mode, does its press, and then switches back to position. All seamless. Some things that are in development, all that software that we've already developed is included in the Vector. That's actually ahead of the hardware. We're expecting some hardware in November timeframe. We're going to be doing some testing and hopefully get this thing out to you guys in Q1 of next year. Some other things that are in development. We're looking to try to do some higher speed capabilities. We're looking at a higher flow manifold, some larger pumps. We're also looking at a press package, integrated solution. We have the actuator, we have the controls. We're looking to put together an HMI, a nice press package, and then go after like the ProMass or other press packages out there in the world. So getting your input into this is appreciated. This is what we're looking at doing sometime in the near future. We're investigating these things. So again, give us your feedback on other items that would benefit you as well. Feed that back to your RSMs. The AOI is progressing really well. The software is actually done. Giving you some insight. It's a simple setup. You can see here's a block. You would enter in your various need, your force, min, max, pressures, your feedbacks, where it's coming from, scaling, all your same control capabilities are included in this AOI that I mentioned earlier. Feedback going back to the PLC. As needed, you can do your position or force control, and it's again seamless in this AOI as well for the Rockwell solution. S runs the AOI in a PLC. And we're still looking for beta sites. We have some. We're still looking for some more. The code is ready to go. Our documentation is being developed. Example code is being developed. We'll support you as needed. If we get some beta sites, we'll do a lot more support with the beta sites and help and get things running. FYI, Rockwell's also looking at a press template for a Rockwell motor drive and HMI along with the Kyntronics actuator and AOI software solution. Martin, new material continues to be.
Hey, Oscar, can you put yourself on mute? You're overriding Carl there. Thank you.
Okay, got it.
Thanks, Jeff. So new material keeps on being added to the marketing. Application success stories. We're doing some videos that should be out in the next few weeks. Updated PowerPoint. You've seen some things on this PowerPoint that are going to be added as well. So leads from the website. We're always trying to stay high on the Google searches, SEOs. We're doing some vertical email campaigns, and hopefully we're going to get you guys some leads from all this effort. Follow us on LinkedIn as well. So quickly, I'll go through, went through this before with you guys, but what's active today? There's some sectors that aren't too active, but there's definitely sectors that are active. Food, people are drinking with all the craziness going on in the world. Paper is being used. Fitness equipment, barbells are there's a shortage in that world. Home improvement, real estate world's going crazy. Ammunition, medical, military are all active sectors today. Packaging is booming. Extrusions, bottling, those sectors are booming. Lumber is booming because of the home. So there's things that just wanted to put this out there to get you guys thinking about some sectors to target. We continue to be successful regarding replacing hydraulic systems, mechanical actuators, a lot of success there as well. Having issues out there, that reliability thing is coming back to bite them, and we're taking advantage of that. Presses, testing are still very popular for us. So the next couple applications, just wanted to show you some unique things that we're doing. This is a large valve control application, 90,000 pound force. Something to point out, it's a small little motor. So this guy is just regulating force. It's a slurry-ish type of material that's flowing through that we're controlling through a valve. In this situation, this compound slurry thing can get up to a certain amount of pressure. And what they wanted is a ability to dump quickly. So we put a solenoid valve in the back of here, and if there is too much pressure on the front of the actuator, safety reasons, they want to be able to open up that solenoid, and the actuator zooms back based on the pressure of the slurry, pushes it back really fast in that 10-inch or 15-inch per second. So all that flow needs to be sized properly, and that goes back. So anyway, this is a good example for a safety that the system will pop that valve right back, and it's a good process control, safety control feature. This one was installed overseas. Mold maker, press manufacturer. This is a unique application with a through shaft. They required a through shaft to fit onto their machine. This is, again, a unique situation. The volume is the same on both sides of the piston. Therefore, you don't need the reservoir. And that was all required to properly fit on a machine. And so they would not have to modify their machine. So this was a 16,000 pound force. Actuator replaced hydraulics. They didn't want to go down the road of EMAs because of the shorter life, and chose a solution. Wrapping things up, the all-in-one solution. Don't forget about that. And the apples to apples, our focus is trying to make the complex simple. Because the actuator is much more simpler, it's a much more reliable, efficient solution. and follow us on LinkedIn and let us know how we can help you guys out. Any questions?
Can you hear
Can
me,
we get a
Carl?
copy? Can you put a copy of this prezo out?
Yes, it's being recorded, and we'll send you the recording, as well as we can send out the copy of the presentation. Just contact your RSM, and we'll get you a copy of this as well.
Good. Yeah, I'd like to share it with my sales guys.
Fantastic.
Hey, Carl, Mike Allenbach here in Atlanta. One of the things I typed into the chat box on pressing applications, you know, we're finding that with all of our past experience with EMAs, like roller screws, notoriously bad in pressing applications because you have so much pent up inertia in the roller screw and the motor rotor that trying to stop when you reach a pressing force is almost impossible. And so the pressure control and the ability to stop quickly is so much better in the SHA, you know, the hydraulic actuators. So thought that was worth mentioning. And then also typed in there a question on your valve. That's very interesting on the valve applications. Any capability with the SHAs to like fail open or fail close on a valve application? Have you ever been asked that or put any thought into it?
We have been, and yes, we can do that on the various apps. That's the beauty of the hydraulics. We can control that fluid to move in one direction or the other for safety applications.
Yeah,
That's good.
That's pretty interesting on the valve control. I like that.
Now, it's a really good point you mentioned regarding the press. It's a very good point regarding the inertias and things and the failures on the roller screws. We're seeing that out as well.
Well, we got in big trouble on one application because they just simply, it was like a big roller screw integrated unit, and they just couldn't stop it fast enough. You know, it was like a GSX 60 unit, and there was just so much inertia there that they wanted to wrap it down, sense a force feedback through a load. They even had a load cell on it, and they just couldn't stop it quick enough. You know, there was overshoot, which on a pressing application, overshoot will kill you because you can't unpress it. You know, so
Exactly. Thanks, Mike.
Yep. Thank you.
Anything else we want to go over that I'm missing here? I'm sorry, I didn't. Was there a question there?
Yeah, you know, on the side, you know, so no side load at all, or the stop tube does up with some deflection of the side load.
Yeah. So no. Yeah. So we all, everyone in the actuator world tries to promote to avoid side loading. Of course, that can't be done perfectly. And the point that was trying to make is EMAs, they can't have any side loading. With ours, the hydraulics world, we can deal with some side loading, and those type of methods are ways to deal with some side loading. Obviously, too crazy, it's going to affect it. But yes, so we can deal with some side loading, some applications, all kinds of different applications with the levers and things like that. If we know that up front, we can add the stop tubes and do the various things to try to prevent and help in that situation.
Okay, great.
Anything else, gentlemen?
I'm good. Appreciate it, Carl.
All right, appreciate it.
Yeah, really good, Carl. I just want to mention there's a lot of applications out there that just automatically introduce side load as much as you try to reinforce it. Vessel lids, any kind of a tipping axis, dumping bins, that kind of stuff. And that's where your hydraulics really pay off because they can withstand that where EMAs are just going to fail.
Hey, this is Joe from JM Grimstead. Is there a typical rule of thumb about how much larger EMAs need to be sized to achieve the same life as a SHA?
Rick, are you on the phone still?
Yeah, I'm here. Yeah, no, there's such a wide variety of reasons that drive mechanical actuators life that there isn't like a rule of thumb. In fact, I mean, that's kind of the important thing is that the life of a hydraulic-based actuator is just a totally different mode than the life of electromechanical. So electromechanical is quite simply, it's fatigue failures. So electromechanical actuator will fail through fatigue, okay? Now, the nice thing about that is it's predictable to some extent. For hydraulic actuator, our first failure mode is going to be a seal, and that's a friction failure, which isn't as predictable. But yeah, it's two totally different applications. So you just have to look at it case by case.
Anything else? Oh, feel free to reach out to me or any of the RSMs if you guys have any questions, and then we'll get back to you. I appreciate you guys' time, and